g of x is equal to x minus 2 all over x squared minus 2x minus 3. And here we're just asked to find the asymptotes and the intercepts of the function and to graph the function. Now when they say intercepts, they're talking about the zeros of the function. And that's interesting. So the first thing that we need to do is I would guess, figure out what the zeros of the denominator are. So we would need to take x squared minus 2x minus 3 and factor it and say that it can't equal 0. So I just like to guess it and check on these simple quadratics. I write the first term, I write the last term. Only way I can get x squared is x times x. To get a negative 3, I need a negative 3 times a positive 1 probably. Let's see if it works out. Negative 3x, positive 1x. I combine like terms. Yep, that equals my middle term. So this whole thing factors to x minus 3 times x plus 1 cannot equal 0. X minus 3 cannot equal 0. X plus 1 cannot equal 0. Or x cannot equal positive 3. Or x cannot equal negative 1. All right, cool. Now to find the 0 of the function. So this is our domain restriction. All this work right here, all of this, we did to find our vertical asymptotes. Okay? We have vertical asymptotes that x cannot equal 3 and x cannot equal negative 1. That's it. And we use zeros to do it. But to find the x-intercepts, we need to do something different. This whole fraction becomes a 0 when the numerator equals 0. Does that make sense? When the numerator equals 0, it doesn't matter what we put on the bottom. 0 over 9 million is 0. 0 over 2 is 0. 0 over pi is 0. 0 over smiley face is 0. Okay?
0 over 0.
0 over 0, that's different. But we'll check for that. I said that as a joke, but we'll check for that. So what I need to do next is I need to say x minus 2, because that's the numerator, equals 0, and I need to solve that. So x equals 2. Now this is the x-intercept of the equation. Now, to make sure that it's not 0 over 0, I need to double check that with my vertical asymptotes. If one of those vertical asymptotes was 2, in other words, x cannot equal 2, then this would not be the x-intercept because I couldn't plug it in because the function wouldn't be defined at that point. We'd have some discontinuity. Does that make sense? Which does happen sometimes. So we should check for 0 over 0. All right? But in this case, it doesn't. All right? So what was the other thing they wanted us to find? Oh, to graph it. So now if we go to graph this, x cannot equal 3. We're going to have a vertical asymptote. And then again, at x cannot equal negative 1. Now if I go to graph this, it may go like this. And then this will come down. Where will it cross? Right there. And then this will probably do, it might go like this, it might come like this. But we're going to have some sort of behavior like that. The other thing is, and I'll show you guys how to do this later. You could have something like this. It does all kinds of crazy things. So now we're going to graph it on the graphing calculator and see how close we are. Okay? So we've got the quantity x minus 2, all right, all over the quantity x squared minus 2x minus 3. And then I'm going to hit graph. See how that works?